So we're going to start off by looking at measure of central tendency. So this is looking at measure of location here. So what is a measure of location? Well, measure of location is looking at a single value which describes the position of a data set. That's essentially what we're looking at. Looking at a single value that describes the position of a data set. So this single value could be one of many things. Okay, it could be a mean, it could be a median, they're single values, or it could be a mode, and they are single values used to describe the data set. And in this case, median, mean, and mode represent kind of averages, so they describe what we call a measure of the central tendency. It describes the center of the data, i.e. what is most likely. Median, as you know, is the middle value once arranged in order. Mode is the most common one, and mean is taking the sum of everything and divide by how many there are. They tend to give us what is like the central location of the data. So if we have a list of 100 data which represent heights of students, then the mean, median, and mode are likely to be kind of in the central position of those values. So that's why we refer to them as measure of central tendency, the mean, median, and mode. Now, there are other types of measures of location that we use as well. We use lower quartiles, we use upper quartiles. Now, the lower quartile represents the position at the 25th percent quartile position. Upper quartile represents the value at the 75th percent position. Okay, as we know, median represents the mid value, the 50th percent value. Likewise, we can also look at, so in addition to quartiles, we can also look at percentiles. We can look at the 30th percentile. That means we're looking at the 30th percent position. What is the value at the 30th percent position? So these are all, as the keyword here, measure of location. Okay, so how do we find a specific value at a particular location? That process involves doing something called interpolation. So we talked about measure of location being indicated by median, mean, or mode, or sometimes an upper quartile or lower quartile. So that's measure of location. That was what we looked at. Now we're looking at measure of spread, and a measure of spread essentially shows how the data is spread out. Okay, how the data varies. It's a measure of dispersion. Okay, a measure of variation. The higher the measure of spread is, then we say the higher the variation is within the data, or the dispersion is within the data. And commonly what you've seen before is range being used as a measure of spread, interquartile range being used as a measure of spread. And here we already know those. In addition to that, we can use interpercentile ranges, which is essentially, it could be for instance, if we're asked to find the 10th to 90th interpercentile range, it's essentially finding out the position of the 90th percentile, position of the 10th percentile. What are those values? Take them away, and that gives us the interpercentile range for 10th to 90th. But in addition to that, we are now looking at standard deviation and variance being also used as a measure of spread. So let's go and take a look at how we work out variance and standard deviation. There's two types of data that we'll look at. We'll look at raw data and we'll look at grouped frequency. And you need to be able to work out variance and then standard deviation from both of those. So what's given to us in the formula book? That's an important point to start off with. Then you can figure out what you need to remember. So in the formula book, what we are given is this. So as you can see here from the formula book, there's only kind of this one here given, which is an indication of using raw data, not the grouped frequency, this one here. Okay, so they've given us standard deviation, how to work that out. We know that standard deviation is the square root of the variance, so keep this in mind. So we've got to the raw data standard deviation formula given to us, but not the grouped frequency. So where is this grouped frequency one? Well, you have to actually learn it yourself. So let me just highlight what was given to us in the formula book was essentially this. In other words, this, they gave us this. Okay. Notice here that this sum of x over n, that represents the mean. So we've got the mean squared, and the formula book has that, which is the mean squared, x bar squared. So mean is often represented as x bar. So that's how it's written in the formula book. So you need to know the difference, how it's written in a formula book and how you might have to then go and do the calculation for it. So we've got the formula written in terms of raw data, and then the grouped frequency, grouped data, we can find the standard deviation from group data as well. Now, this is not given to you, but you need to memorize it. Now, the easiest way of remembering this is as follows. So what I tend to do is I tend to learn the one from the formula, which is, this is telling us to find the mean of the squares. So that means squaring each x value, adding them up, and then dividing by how many there are. So that's the mean of the squares, minus, this is referred to as the square, i.e. squaring the mean, square of the mean. And that applies in this case as well in the group frequency. So if you remember this phrase here, mean of the squares minus the square of the mean, and understand what that's actually saying. So you square each value and you find the mean of that by doing the total of them divided by how many there are. So that's the mean of the squares minus the square of the mean. So there's the mean and you square it. So that's why it's called square of the mean. Now, if we look at the group data frequencies, in terms of frequency, it's the same thing. So this here represents the mean of the squares. So you square each x value, times it by the frequency. So mean of squares. And this, as you can see here, the sum of fx divided by sum of f is the mean. So this is the square of the mean. Okay, and it's the same thing in both of them. So if you remember this phrase, you can actually use the one given in the formula sheet and then derive the frequency one. If not, you just need to memorize them both. There is no shortcut to it. Okay, so let's go and take a look at how you would use that. Now, in order to use that, we'll first of all look at coding as well and what that is, and then we'll look at everything applied into a question. We'll look at interpolation, coding, as well as standard deviation, all applied to a typical exam style question. So what is coding then? Well, coding is a way of simplifying a statistical calculation. You're essentially taking large numbers perhaps and using a code such as taking away something and dividing by something to reduce the size of the numbers. So if you do code something, it might be then that you have to decode it and go back to the original. Okay, so you might find y by using x take away a over b, but then you might have to go and find out what x is again. So how does coding affect standard deviation and mean? They're the two main things that we need to know. So for instance, if we had a mean and we multiplied the mean by something or divided it by something and subtracted something to it, then the standard then the mean of the y would be affected in the same way. So if all the data, if we subtracted something from all the data and then divided it by something, so if we subtracted a from all the data and then divided it by b, then the mean would be essentially take the mean of the original one and subtract a from it and divide by b. So the mean is affected in the same way as the data is affected. Okay, so the mean is affected in the same way as the original data was affected. Standard deviation, on the other hand, is slightly different. The standard deviation is only affected by multiplication and division. Subtraction doesn't affect it. And the reason for that is, suppose I had a range of data such as 2, 5, 7, 15, and suppose I then added 10 to everything. If I added 10 to everything, it would become 12, 15, 17, 25. If you look at the range, the spread of the data for this compared to the spread of the data for that, the range hasn't affected. All I've done is I've shifted everything up by 10, or I could have shifted everything down by 10. So standard deviation is a measure of spread, and spread is not affected by adding or subtracting. Whereas if we did times them or divide them, then spread is affected. So that's why what we when we use coding, when you do adding or subtracting, it doesn't affect standard deviation, but multiplication does. Whereas mean is affected by both adding as well as subtracting and multiplication and division. So the takeaway from coding is that in essence, in summary, addition, subtraction, multiplication, and division affects the mean, whereas addition, subtraction does not affect standard deviation, but multiplication and division does in the same way.